Okay, so you guys are here for configurations and equations and global variables and stuff and design tables, and so it looked like it was pretty wide spectrum for you guys. There is going to be 2 sessions of this. This one's going to be the first session. We're going to keep things somewhat low intensity, and then on the second session we're just going to deep dive a little bit more, get into assemblies and stuff like that. So this one we're going to kind of hang it low. We're going to look at what configurations are. We're going to show you how to use equations and what global variables can be used for, certain ideas and stuff like that, and then definitely get into design tables and how they kind of interplay and react with everything as well too. So the main thing that we have here is a tale of 2 parts, all right? Multiple personalities. So the 2 parts that we're going to talk about, first one is going to be configurations, what they are, what they're helping out with, and all that good stuff. And then we're going to go through and we're going to take the same part, but we're going to change what we're using it for, what we're doing with it, what our intentions are with it. So I want to kind of hit upon those 2 particular things there. The first thing I want to do is I want to get into is configurations. And configurations basically allow you to create different versions of a component and keep it in a single file. So one of the ones that I usually will talk about is fasteners. If you have a 1/4" socket head cap screw, you can usually come up with a lot of variations. Even it's just the length of it's changing. Everything else is staying the same. You take that 1/4" socket head cap screw and you add other diameters to the shank and stuff, and now you've got another complete set of numbers with the length of it changing, and then so on and so forth. In fact, if you take a look at it, if you ever get really bored, under the ANSI standard, there's about 11,000 socket head cap screw variations available out there. And why would you deal with 11,000 variations of files out there? So do I want to manage 11,000 files, or would I prefer just to manage 1 file? And with configurations, you're able to do that, okay? That's a little extreme. Please do not handle 11,000 configurations in a file. I'm just saying. So during the configurations, some of the things we'll talk about is our heavy hitters inside of configurations. What can you control? Primarily what we like to play around with is suppression states and dimensional changes. So I want to kind of talk about that a little bit. And then once we get done with configurations, basically there's a couple methodologies. The one I want to hit with you guys is a manual configuration method, and then we'll talk a little bit about the design table to kind of get that and make it a little bit easier and a little bit easier to make and easier to manage as well too. So let me jump into SOLIDWORKS here, and I'll get into, let's see, configs 1, and we'll bring up a flange. So a basic, simple flange, something that you would probably see out there. It's a casting, and so one of the things that we talk about variations would be something like this. This particular flange isn't going to be casted 100% complete, all right? If you're going to make a casting like this, you're going to probably cast out the original or outside shape. You might have some of the holes there, but they're going to be a lot smaller, and then this is going to go to a machine base or a machine operation afterwards to ream out the holes, make them the right size, maybe even spot face the bottom edge of it as well too, so it's a flat face. So this is going to be a perfect application to utilize configurations, because the part is kind of in 2 states. There's a cast version of it, and then there's going to be a machine version of it. Other things that you might run into on a regular basis as well too is going to be sheet metal. If you kind of think about sheet metal comes in 2 variations, right? You're going to have the form method, and then you're going to have the flattened state. So you always want to be able to flatten it out. And if you've ever done sheet metal, show of hands, how many of you guys are doing sheet metal inside SOLIDWORKS? All right. How many of you guys use the flat pattern from SOLIDWORKS? All right. You're using configurations at that time. So I've run across people that are real big fans of configurations, and I'm like, oh, do you do sheet metal parts? They're like, oh yeah, I love it. It's great. Okay, you're using configuration. Sorry to say it. So keep an eye out there for that. Now, one of the things that we have here is I can go ahead and look at this. We'll see what's going on. Your configuration manager is the tab in the middle up at the top. This is where all your configurations are going to be stored. So whenever you're going to be dealing with them, this is the tab you're going to want. Some of the little secrets inside of SOLIDWORKS is the little bar with the dot on top of it is actually a way to split the table here. So you can actually see your features above and your configuration manager below. It's one of those little things that you kind of see in there. I find out that when I'm dealing with configurations, I end up flipping tabs quite a bit. This gets rid of that because I can actually show, the different variations right there. Now, in a case like this, what I'm going to do is I'm going to take a look at it. And, well, really I have a machine base here that I want to kind of work with. So I'm going to come in and I grab this and I simply do a slow double click on this. It's going to allow me to rename the configuration, and I'm going to go ahead and say that this is the machine base. If I learn how to type, that actually would help out a ton, but they don't pay me to type apparently. And we'll say machine base. And then what we want to do is come in and start adding configurations. Now, look, adding configurations is pretty simple, actually. As long as you're in the configuration tab itself, you're going to be able to come in, right-click, and you'll see that there's an add configuration. That's going to go ahead and start the whole process. Now, when you start a new configuration, there's a couple of key pieces of information that you can put in here. One of them is going to be the configuration name, probably the most important piece of information you can put in there. In this particular case, the configuration name can be used for many different things. One could be a descriptive term, or in certain cases it can actually be a part number as well too, if you happen to have a family of parts. So understand that you have this ability to get in there and do that. Now I'm going to come in and say that this is the forged base. I don't have to put in a description, but we do have some advanced options available as well too. For the most part, I like to use the default ones, although there is times where you might want to turn these on and off, and it's one of the things that I'll probably kind of hit upon in the second presentation there. So I'll go ahead and say OK to that, and I've generated my new configuration. So it works out pretty good. I've got two here, but how do I know which one I'm looking at? Well, under the configuration tab, you'll see that the one that is active on the screen has actually been highlighted for us. So we know exactly which one we're looking at there. The other one is grayed out. It means it's not the active one. And ultimately, you can only have one active configuration on the screen at one time. Now, that doesn't mean that you can't have multiple configurations showing in an assembly or a drawing, but at least in the part file itself, there's no way to show all the variations at once on the screen, okay? So coming in here, basically what I need to do is I need to make this a little bit nicer, a little bit easier to use, and I want to change it up a little bit. Now, some of the things that I might want to do is get rid of some of the hole details that are going on in here. I'm not real keen on them. They're not going to work for the casting. It's going to be too hard to fill them in. I'd rather keep that as a machine operation afterwards, because I can, I got to have some quality and I got to have some good tolerances here. So one of the things I'll do is I'll come through here and I'll simply right click on one of them, and then I'll hit the suppress on there, and that's going to go ahead and get rid of all the holes at that time. So now I've got something that's a little bit closer, but we're going to run into an issue here fairly quickly. One of the things that I try to bring across, especially to newer users inside of SOLIDWORKS, is that you want to try to break your features out as much as possible. There's always been a little bit of a contention about the number of features versus how long it takes, and efficiencies and stuff like that. And what I found through the years is that more efficient parts usually have more features, and the reason they're more efficient is because your sketches are a little bit smaller, and that means that they're easier to rebuild, and the features based on those sketches are usually easier to rebuild based on the fact that it's an easier sketch to work with. So one of the issues you run into quite frequently is that sometimes I will see, and I do myself, is that in the sketch for the revolve that I have going on, you'll see that I have this spacing between the center line and the inside of my shape there. Well, when you revolve that creates a hole. The downside that I have here, where I went to the other holes and I was able to right click and suppress those items out, with the suppression I'm basically telling SOLIDWORKS, don't do this feature, all right? Those holes were cut in on their own, and so when I suppress them, they all disappear. Now the issue I'm going to have here is if I was to get out of this sketch and take a look at it and try to right click and do the same suppression I would do on the other one, the whole part disappears. All right? Reason being, that was part of this original sketch, and that was part of the original feature. So if I suppress it, everything else in the feature manager is going to become suppressed as well too. Not really what I was looking for. Would you guys agree? Okay, so I'm going to go ahead and undo that. And how would I fix something like that? Well, in this particular case, I might want to make the hole smaller. I'm going to go ahead and just shoot the moon and go, you know what, I don't want a hole here at all. This is a very particular hole. Maybe it's being threaded, maybe it's being reamed. I want to just make sure that this is a solid casting throughout all, that I have good material to roll through, all right? So one of the options that I might have is just to simply come in and create another feature. Now, I could fill this up, but SOLIDWORKS has a great functionality, allow me to delete a face. When I come in, I can delete it. I want to tell SOLIDWORKS I want to delete and patch, which basically says get rid of that surface and then heal all the surfaces around it. It allows me to quickly get rid of holes. In fact, how many of you guys have ever had to deal with imported geometry? Show of hands. Have you ever had to modify that geometry, maybe get rid of holes and all that stuff? This tool is an outstanding tool to help you in those situations. Gets rid of holes, gets rid of fillets. If you need to get rid of a feature, you don't have to physically cut that off and make this little hack whack mark on it. You just simply remove the geometry and let SOLIDWORKS heal the surfaces up. I will say, it doesn't work perfectly all the time, but you'd be surprised how many times it does work pretty well. Fair enough? All right, so does this look like a little bit better casting? Sure, I'm going to go ahead and say this might be okay. Now, what I did here was I was in the forging at this point, and I said get rid of the holes, and then I said, you know what, I got to get rid of this hole as well too. Now, when I got rid of the hole, you can see at the bottom I had to add a new feature. This delete face is a feature. Well, now I start thinking, what about my other configuration? Did my other hole disappear now? Do I have to go back to that and fix it? Well, if you're just getting into configurations, you're going to want to always double check the work you get into at first until you understand how SOLIDWORKS works and what the default setups are and stuff like that. The more you use it, the better off you're going to get, the more comfortable you're going to get, and the more quicker you're going to get as well too. So I'm going to go ahead and come over to the tab here for configurations, and I'm going to double click on machine base, and what you'll see is all those features come back. Now what I want to show you is this. If I go back to the feature manager to take a look at it, we'll see that that last feature has become suppressed, all right? And those advanced features I talked about, by default, if I go back to one of the configurations and I actually edit the properties of the configuration, I'll see that down here at the bottom it says suppress features. And if you look above it, it says, hey, if you add something to any other configuration, I'm going to suppress that feature in this one. Now this is actually a default setting, so there actually may be times where you want to turn this off. So when you add a feature in another configuration, it will not become suppressed here. But by default, I will tell you, if you're in a configuration, you add something, all of the configurations will have that suppressed at that time. All right, so that's one of the ways. In fact, if you look at configurations, we kind of talked about it briefly there. We said, hey, there's the ability to, in fact, let me bring it up here. You have your suppression state and you have your dimensional values. So we talked about the suppression state, and you can see that it kind of works both ways. New things get suppressed. You can suppress other things that are there. Well, what else do we want to change? Well, you know, I've got a single flange, but that doesn't really mean much for me. You know, flanges come in all kinds of different shapes and sizes and stuff like that. So this is where we start looking at the family of parts. If I take a look at the flange that I happen to have here, you'll see that it's got a slight angle on it. It's got some ribs on it. It's got 4 holes on it. It's a certain size. You know, these are things that I want to kind of take a look at and see if things are good to have together as a family. Now, if I had a flange that had a straight boss coming out of it as opposed to an angled boss, that might actually be another complete different family. It might have similar features, might have 4 holes, might be the same size, but that one change might be enough for me to kind of look in a different direction. If anything, what I've seen out there with uses of configurations that people sometimes just try to use it a little bit too much. They try to put too many things together in a single part file. And then, you know, I actually have customers out there that have, you know, 200, 300, 400 configurations in part files. And that's really awesome that they have one location to come to this thing, but they're starting to understand that there's a certain limitation to what the program and even the computers can do trying to balance this out. And then also, beyond all that, you have the human interface, all right? After 400 configurations, it's really difficult to figure out what's going on where. I usually tell people to double check configurations. Well, if you have 400 configurations and you make a change, are you really going to go through all 400 other configurations to make sure nothing else happened? Chances are no, mostly because we've got a boss, we've got timelines, we all are trying to hurry, hurry, hurry. So, you know, keep them somewhat limited. You know, the 11,000 pieces, the 11,000 configurations for a single bolt sounds great, looks great on paper. Hey, look, I got one file, it's 4 meg big, it's got 11,000 parts. Everybody's going to go for that. Hey, sit down and play with the 11,000 piece configuration. It's going to stink, all right? Think about the list. How many guys use configurations today? All right, you got your little list. Can you imagine hitting that list and scrolling, scrolling, scrolling? Kind of seems a little bit ridiculous, right? All right, so we've got all our information here. Boss man comes in and says, hey, we need to make another part. Looks just like that, except it's going to be a little bit bigger, all right? It's going to be a little taller, going to be a little bigger, and then maybe we'll run into some things here as well too. So I'm going to go ahead and double click here. And I'm just really taking a look at the data that's in here. I can see that I have a diameter here, I've got a thickness here, I got a height to the actual boss itself, and then I even have another dimension here that I can play with as far as the hole diameter and the top diameter of that flange. So I kind of see everything that's available for me. Where do I want to go from here? Well, boss man comes in and says, hey, flange has got to be a little bit wider, and I need it a little bit taller. I'm like, okay, what do you mean a little bit wider? Well, he goes, well, it's 135 now. I need it to be 150, and go ahead and make it 100 millimeters tall. I'm like, all right, cool, no problem. So I come over here. I create my new configuration, and one of the things that you want to keep in mind is when you create this new configuration, try to get the one that's closest to what you're trying to do on the screen first, because when you create a new configuration, it's based off of whatever's active on the screen now. All right, so I'm going to make a machine version of this. I'm going to go ahead and add a configuration. I'll say taller, bigger, and I'll say machined. Go ahead and say OK to that. And then I can come in and simply modify my dimensions. Now, once again, you need to be a little careful with this. I'm going to type in 150. I'm going to hit enter, nothing updated. Most of you SOLIDWORKS users know you need to rebuild. So I'm going to go ahead and rebuild that. And I see everything get bigger, but let's see. I'm kind of getting into configurations. I've kind of been bit in the butt before. And so I always want to double check. Even today, I'm still nervous sometimes when I use configurations because I'm never quite sure. In fact, I'm pretty sure I just messed everything up right now. Does everybody catch what I messed up? Got a couple people, yeah, okay. So let's take a look at our other machine base that we had in there. And you'll notice nothing changed. All right, so let's take it to the crowd. What did I do wrong?
You changed that dimension for all.
Right, I changed the dimension, and when I hit enter, all configurations were selected at that time. So how much control do I have over that? Well, I actually have quite a bit. Let me go back to the original, or the taller, bigger machine. And I'm going to come in here, going to grab that dimension, we're going to take it back to 135, and I'm going to do an update. Everything's back copacetic. If I double check the other ones, they've updated as well too. So what I want to do is I want to be careful. I'm going to have to say that as far as SOLIDWORKS usage, sometimes my britches are a little bit too big, and I like to go a little bit quick, and I don't sit back and smell the daisies. So I'm going to type in 150, and my whole problem is the Savant hit enter as soon as I type a number in. That's where I screwed up, okay? Now, if you take a look at it for the dimensional change here, I'll go ahead and bring this to the middle of the screen. You'll see that there's a little box over here that only pops up if you're using configurations, all right? Usually it's not there. It's a small little thing. That's why we usually miss it upon the first hit there. If I hit the drop down on there, what you'll notice is that we have a couple of choices in here. First choice is this configuration, all configurations, or you can pick what configuration it's going to take effect in. If you have a lot of configurations and you're trying to change one number in 16 of those 30, you can use that one and actually just pick it from a list. In this particular case, I want to go with this configuration. One thing I want you to know is this, is if you're working with configurations, pay very close attention to the box next to it. If it's got a single little box, it's only going to affect it here. If you see 3 little boxes, you just changed it everywhere throughout the whole thing. Fair enough? So I'm going to go ahead and hit enter now. It's going to work out great. I do my update, and just because I'm a little nervous about it, I'm going to go ahead and check the machine base, and you can see that it is distinctly changing back and forth. Now I did have to do one more change. I'm going to go back to the taller, bigger. I'm going to double click on the top face again, and we wanted to go to 60 millimeters tall. I said 100, but we'll do 60 instead. So I'm going to take this to 60. Don't hit enter. Make sure you grab that right little checkbox over here. And then we can go ahead and say OK. We can even hit a rebuild up at the top. And now we've changed our model pretty quickly there. All right. Next steps. I made a brand new part. Am I done? No. What do I need to do at this point?
Make it forge version.
Make it, save it. Perfect. Yeah, definitely. Save it. Yeah, save often. We will tell you that. Yeah, I need to make a forged version or the casted version of this. So I'm going to go ahead, and it's going to be based off this shape. So then I can come in, right click, add a new configuration. We'll say TB forged or TB casted, whatever it may be. And then I can come in and make some changes. Now I can come back, right click, and suppress. That gets rid of, well, whoa, that doesn't look too hot. That didn't work out at all, did it? All right, let's undo that. Let's get back to where we were. Let's go back to the original hole over here. So we'll right click and we'll suppress this. That seems to work out pretty good. Basically what I'm running into, parent-child relationships, all right? I had a casting there, or I had a pattern in there. I had the ribs and the holes patterned together. If I take if I take any of the patterned holes or pattern features, I just get rid of my pattern. If I grab one of the parent features, we can see that SOLIDWORKS actually works pretty well with it at that point. The other thing that I have here is I can come in here and delete the hole. So I'm just going to go ahead and hit the delete face and say OK again. Now we'll notice that I've already done that previously. You have a question? Yes.
What's the difference between patch and fill?
On the delete face. If I come back in, let me go ahead and right click and edit that. If I were to just delete that face, basically what I've done is I poked a volume into the surface or into the solid, so it turns it immediately into a surface model. The other one that we have here at the bottom is delete and fill, which puts in what we call a patch surface or a filled surface. And so it'll delete that surface and then try to repair itself by putting a surface back in to cover it up. Unfortunately, it ends up putting a hole back into it. So it looks like I did nothing, but actually what I did was I deleted the hole, and then SOLIDWORKS said, oh, I'll fix this for you. Let me put a surface in, and it put a surface hole in. All right. Now, it did sew it back together, and it is a solid, but it's completely not what I want. So in a case like this, we'll come back in, I'll edit that feature, and I'll do a delete and patch. What a delete and patch does is it says that surface that was broken, I'm going to just heal that hole and seal it back up with the original geometry that might have been there. Kind of make sense? All right. All right, so basically what I have here is I got a couple variations, all right? So as far as configurations go, it seems like it's a little bit of work. I have to manage it a little bit. And I talked about the number of files and stuff that would be available. Why, in a case like this, does anybody have any good ideas of why it would be a good idea to keep these files together? I mean, I could do a file save as and do the same work to it, not have to worry about messing up other configurations or anything like that. So what would be a driving reason in these particular cases to use configurations? Any ideas?
Too complicated.
To repeat over and over and over. What if I have my machining and I have my, I have my machine version and my cast version. If they are in separate files, what if one got bigger? Would the other one automatically get bigger? No, not necessarily. So while it may be a little difficult to work with configurations, if you're careful with it, you actually get a lot of benefits out of it. Things stay together. It's nice to go to one location to find all 4 different versions of these files. But once again, don't get into the habit of having hundreds, if not thousands, of configurations in one file. It really does flip on you at that point. It becomes a burden as opposed to a boon. So we got those together, and really, that's the manual method. You get in there, you double-click dimensions, you change them, you add configuration names, but you start to get to certain points where this might be a little bit of an overhead. If I needed to quickly make a new configuration, especially in something like this, I'd have to go in, create the new configuration, suppress what I don't need, add what I do need, change dimensions that I need, and it is a process, but we can make this process a little bit easier. So this is where design tables come in. It allows us the control of configurations, but it kind of organizes in such a way that it makes it easy to deal with. Now, to see a quick example of something, what I could do is this. Let's see, do I have it out? No, don't. I'll show you another part here, and I'll show you a design table before we actually get into it. And there we go, plate. We talk about configurations, and if you want to see an easy thing to configure, Legos, right? So you look at a Lego plate like this, and how many variations of those have you ever seen? So how many of you guys are familiar with Legos? Everybody, right? So, in a case like this, especially like instructions, we have things like, this is a 4x6 or a 6x4. It just depends on your terminology. And if I take a look over here, I've got my configuration manager up right now. And you can see that I have quite a few different variations. I've got the 12x1. Just double click on it. There's that one, and I've got the 16x2, and I've got a 1x1. And meanwhile, what's happening underneath here is you'll see that there are certain things changing. So you'll see that there's little pegs there, but if I go to a 10x2, you will see that there are little barrels that are going to show up underneath here. And so now there's the barrel. So basically what I'm doing here is in my configurations, I have to control the numbers on my patterns, the X by Y. I have to control whether that feature is on underneath. And then I have to control the number of that feature, because that's always 1 minus however many I have. So if this is 10 little things wide, I only have 9 of those in the middle. So there's a lot of variations that are coming in here. And for me to come into the configurations and open them up and add a new configuration, figure out what numbers are switching, suppress whatever needs to suppress, it becomes a little bit of a headache. All right. To get this down a little bit more, I can look at it from a diagram standpoint. If I had a nice little punch list, a nice little table, that would actually help me understand what the heck was going on. Now, in this particular case, I actually used a design table to do exactly that. It makes my life a little easier. Now, when you first take a look at it, it seems like a bunch of numbers that's going on in here, but really what I'm doing here is this. Over here in row A, I'm sorry, column A, these are the names of the configurations themselves. That's how they get put in there. If I go all the way to the top and look at row 2, these are all the things I'm controlling. Now, the problem that I have with design tables is I'm not a programmer by trade. So when you start putting @ symbols and $ in and stuff, I get a little confused. I get glassy-eyed. My brother is actually a programmer, and he tries to talk to me. He's like, oh, it's simple basic. And I'm like, I don't care, whatever. And I just kind of go on my own, right? But basically what we're doing here is we've got an XDIM, a YDIM. I've renamed the dimensions so that's a little bit easier to work with. Over here we've got the patterns. We have whether the pattern is showing or not, and then we actually have the number in the pattern as well too. So I can say show this feature, pattern at this much. Okay, I'm not showing that feature, so suppress that pattern and turn on this pattern. So if I take a look at it, let me go ahead and click out of here. You know, I have these dancing features. You'll see I've got a couple features suppressed and turned on and stuff. The beauty of the design table is this. I come across a piece that I never had before, a 36 by 2. So I go and I look through my little parts that I have on there. I find a 20 by 2. I take that whole little row, copy it to the bottom, adjust the numbers real quickly, say okay, got the part done. Already done. In fact, on a good day, I can get in there and probably create in about 15 seconds. So way easier than going and creating a new configuration, figure out what features I want to control. Now I'm just copying a variable down and I'm just adjusting the whole thing. In fact, with the design table, you can even go a little bit farther and you can make it more intelligent by adding equations into the design table that will start running numbers. You can have validation in there. You can do anything in Excel you can do in there, all right? So sometimes I get people that are a little like, well, you know, I don't know what I can do in there. Okay, do you know Excel? Yeah, I do Excel stuff all the time. Have you made really cool stuff? Oh yeah, I've done this with a flip table and does this and this, and they say stuff I don't even know you can do in Excel. But in the end, I just go, do that. And then they're like, well, I don't understand how. You know how, just do it, and then I'll show you how to click it in a little bit later, all right? So let's talk about this design table. I'm going to go ahead and get back into my part. I am going to take this part and I'm going to close saving, and then I'm going to reopen here briefly. So we got the flange, and the only reason I did this is I wanted to clear out the memory. I want you to see that under configurations there's nothing here at this point. So what I want to do is I want to set up a design table that I can control the features, I can turn them on and off, and I can control the dimensions that I need to. Now the way I'm going to do that is I'm going to go ahead and insert a design table. So I'm going to go to Insert Table Design. Hello. And then I'm going to go ahead and you have a couple choices here. And these choices are actually pretty beneficial. If I would have kept my configurations in there and I didn't want to build a new table, I could have used the auto create function that was sitting here. The beauty about the auto create is it will actually go through all the other configurations, figure out what has changed between the configurations, and then it will populate a table with all those changes ready for you. All right. I'm going to go ahead and create mine from scratch just so you can kind of see what's going on here. Now I'm going to go ahead and make it blank. And I am going to have mine buried into the window. There is an option to edit a design table in another window. The only thing you need to know about that is if you do it this way, you don't save it, you don't do anything, you close Excel out. That's what transfers the information back into SOLIDWORKS, all right? Where I see people sometimes make a mistake is they'll have one Excel window open and they're doing some stuff in Excel and then they decide to edit a design table in another window. That puts it into the same window. Now you have a problem. How do you get rid of your other file without losing your data? Just be careful with it. So if you're going to do it in another window, your best friend, don't have anything else open in Excel. Just keep it local to that one. I'm going to go ahead and say OK to here. And we're going to go back and review this. So anything in column A, this is going to be the name of the component or the name of the configuration. So some of the stuff I had here was machine version, Oh, there you go. Here's my Excel skills. Woohoo! Top level, right? Machined, cast, and then I had a tall cast and a tall machined. So we got those in there. Those are going to be my new configuration names that are going to come in. And then I have my row here, all right? Whatever you're going to control, it's going to be in the row. Now, the best way to do this is your best friend. You can look online, you can look in the help file, they'll tell you all the little gobbledygook things that you can have, but one of the things I wanted to control was the state of that hole that was here. So I'm going to go ahead and just double click on the hole. In fact, I'm going to come here, I'm going to find that cut extrude, I'm going to simply double click on it. When I do that, it's going to enter the value for it up there. If you double click on a feature, you're telling the design table that you want to control the suppression state of that, whether it's suppressed or unsuppressed, on or off. The other thing I wanted to control here was a dimension. Now, the dimension I need is in the base. And in SolidWorks, if I want to see a dimension of a feature, I simply double click on the feature and the dimensions are presented to me. Do you see the little downside I'm going to run into here? I'm going to have to come over here, double click on the flange, and then I can see the dimension I need to adjust, but notice what happened when I double clicked on the flange. It said, oh, you want to control this as well too. No, not really. That's not what I wanted to do at all. So I'm going to go ahead and come in here and right click on the cell or the column and then delete it. Now it's not controlling it. That's how easy it is to change it. I'm going to come back in here and pick the right cell, and then I'm going to double click on my dimension, and at this point what happens is it'll grab that dimension name and put it into there. In fact, this is the address of the dimension. You'll see it's D3 at sketch 1. You can modify this, and if you're going to be doing a lot of configurations with the design table, it's well worth the time of modifying the dimension names. Does anybody know how to do that? Got a couple people? Would you guys like to see how to do that? All right, so let's do this. I'm going to go ahead and, for just grins and giggles right now, I'm just going to go ahead and grab this and copy it down. And I'll go back and grab the items later. Really what I want to do is fill in the table appropriately so SolidWorks didn't error out on me. This is kind of an interim state. And did I want to finish it all at one time? Sure, I'd like to, but I went, man, I don't like that D3 at sketch 1. All right, so I'm going to change that. Now, it will tell me that it's created new configurations, and we're going to go ahead and accept that for now. I'm going to come back and double click on the same feature there. Now, you'll see that the 135 has been added to the design table. Can everybody see what's telling me that? Yeah, the pink, the magenta dimension. So if you ever get into a part that you've never messed around with and you open it up and you double click on a feature and it has a big pink dimension, don't mess with that. That's probably not what you want to play with. There's a design table running that number, and you're going to have to dig a little bit deeper into that part. Okay? Now, I want to change the name of this, and the way you do it is you double click on it. But Ryan, I don't want to change the value. I know. So you'll see the values highlighted underneath, but does everybody see the dimension above it? All right, so what I want to do is I want to change that name, and the way I'm going to change the name is I simply highlight the area, and you'll see it reverts to D6. And this is the reason it has D6 there happens to be the 6th dimension I made in that sketch. All right, now you can't control the sketch 1 directly. I can't change that there, but if I modify the name of the feature sketch 1 to something else, then it would also update the address at that point. So I'm going to come in and I'm going to say that this is the flange diameter. Nothing is helping me spell, apparently. Nothing stops you anything here. You can put them together. You can do that camelback, like SolidWorks puts the two capitals together, and you can do anything you need to. Last I heard, it was 256. I haven't got in there. Don't write a letter to mom for the names. That's really what it comes down to. Okay. So we're going to go ahead and say okay to that. Now, one of the issues that we used to run into, and something that SolidWorks has fixed through the years, is that I would have just broke my design table at this time, because it said D6 at sketch 1, and now I have no D6 at sketch 1. The beauty of it, though, is this. Come over to configurations. Here's my table where it's being stored. I can right click on it and I can edit it. Now we'll let it open up. It's going to pop up and ask me a couple questions. I don't have anything changing, so I'll say okay. And we'll see that there's a quick blurb up there. Now it says flange diameter at sketch 1. All right. But if I click off of it, typical Excel, you've got this, you got to stretch the cell out, you got to do all kinds of things. Well, remember, it's a full-blown Excel here. So I'm going to right click, do the format cells, come in and do the alignment. And then we'll go ahead and rotate this sideways and say OK. And then I can go through and simply double click the cells to make it a little bit nicer, a little bit more compact. If you want to go ahead and add in highlighted cells, feel free to do that as well too. Remember, it's the full power of the package this time. All right, so I'm going to go ahead and fill in the machine information I needed here. So this will be 135. We were taking this to 150, taking this to 150, and then I have to work with the U. Okay, U stands for unsuppress. It means it's showing. I need to suppress these holes out. So what do you think I put in for that? S, right? You can also use ones and zeros. You can also use S's and nothing. There's a couple choices that you have. Just don't get too fancy. And actually, when I pick on it, you'll actually see what is allowed in there and not allowed in there. All right? All right, everything looks good to me here. I've adjusted everything I needed to. In fact, what I need to do is double click on the feature and add the hide in here as well too. But I messed up because I didn't have the cell highlighted first. So let's go ahead and get in here, double click on the cell. That says 40, so this will be 40, this will be 60, 60, and we'll be able to get out of there, let it grind a little bit, and it's now updated all of my configurations with the new data. Okay. Now coming through, you'll see that there's a symbology change here as well too. You'll see that there's a little box next to default, and you'll see the other ones fall underneath the X. You can intermingle design table configurations and manual configurations together. It's actually something that I do frequently, usually for simplified parts, for FEA versions and stuff like that. It's not something I want to control through a design table. Now, I will go ahead and go to the machined. That looks good. I got the cast. That looks good. And I got the tall cast and I got the tall machined. But I'm seeing a little bit of an error. The hole in the middle never disappeared, right? Well, I didn't have a feature there, so maybe that was one of the things that I should have planned ahead. And that's really what it comes down to with configurations. A little bit of planning ahead works out really good. Name those dimensions before you start. Add the features you need before you start. Even if it doesn't make sense to add that feature in because it's supposed to be in another configuration, just add it in anyway. It's going to make sense to put it in a little bit later. Well, I'll go ahead and fix this to get it back to normal. And all I really need to do is come in, delete that face. And then I can come back through to the table, edit the table, and then I'll come back in and hit the delete face. Here I need it unsuppressed in the machined. I need it suppressed here and suppressed here. Oh no, see, I did it all backwards. Thanks for the moans and groans. I wouldn't have figured that out. Woo! All right, we'll click out of it and we'll see it update. In fact, we've already seen that the hole disappeared here, obviously. But then if we check the other configurations, that's the tall cast, that's the tall machined, that's the machined, that's the cast. Dang it, man. No, it says suppressed there, doesn't it? Tall machine should not be there. No, it keeps on turning it on. You'll never guess what program I happen to be using. Ta-da! There's SolidWorks. All right. You'll never guess that that actually worked like 2 hours ago when I tried it. So, and Bruce, you saw me do it, right? Thank you. Yeah. So, delete it out of your table. Delete the table. In fact, you know, sometimes you just want to do that. Let's get in here. The fact of the matter is the Excel table is actually stored within the file, which can cause corruptions periodically. And so you'll call up your tech support person, and they will, you know, say, "Oh, it's easy to fix. Just delete your design table." And you're like, "Ooh." All right, it's not too bad actually. I am going to make sure it's suppressed here. It's still. Well, I guess that'll fix it, won't it? Holy crepe. All right, well, let's see if it works this way. Insert table. design table. I'm going to do the auto create. Let's see what it comes up with. Oh, a whole bunch of stuff. Here you can see they put the suppresses and blanks in there. Let's see, state of the delete face. And, you know, yeah, that should work well. I can't see anything, so let's scan through and pick out. It's going to hook all these up. And then let's just modify this in a table on the side. There we go. So default I don't need. Machine, cast, tall machine. It says unsuppressed. Look at that. I broke SolidWorks. All right, let's get out of here. Oh, now I can't even find a ballot table. All right, watch this.
You need to delete the first one.
Watch this as it spirals out of control.
That's why you don't.
See, now you got it recorded, you can send that right to SolidWorks.
That's right. Yeah. They still won't believe me. All right. So we got configurations that we put together in there. We did it by hand. The design table, I don't even know why it's doing this. You know, you go through things and everything should work great. I think if any of you guys were in the last presentation, I think the same thing happened. Does it kind of make sense to everybody? Did you a little bit more information, a little bit more insight in certain cases, a little bit more? See, it happens to people like me as well too.
You create the table in Excel first. Does it still store it in the file, or where does it get stored?
Well, if you create it outside, which is highly unlikely and a big headache, which you can do, what I have done in the past is I've protected my files that way. So what I'll do is I'll create a design table in SolidWorks, I'll copy it, put it into an Excel file, put that Excel file in a network location that only I have access to change, and then I go into my part and I hook it up to this external file at that time. I have seen people actually create a design table from scratch. They're like, oh, it's D3, a sketch 4, and I'm like, what are you even doing? That's just crazy. So if you leave it as it is, like I had naturally in there, it is stored within the part file. And there have been times where you'll open it and you'll try to edit your the Excel file itself, and it'll pop up and say, sorry, file's been corrupt. There's not much we can do on those. If you call us up, what we're going to tell you is that you have to delete your you have to delete the table, and then you have to reevaluate it and put it back in. The last one I had like that, unfortunately, the guy had a lot of equations inside of his Excel table that was running a lot of numbers. So it would make all the variations, but they were now dumb numbers. They wouldn't update as necessary. And so that was really the worst case I had. I did tell him to take that file, recreate it from scratch, unfortunately, but put it into an external one. And that way that could be backed up on the network on a regular basis.
You can't just copy paste. Two windows open of Excel. You know, open Windows Excel.
You could, but then you get in that weird thing about opening Excel. Yeah, it gets really weird. And I haven't tried it lately. I know last time I tried it, it was real dicey about the fact that it didn't like the embedded window and Excel running on the side. And so it gave me a little bit of an issue. So what I did was I did the hope and prayer. I copied it. I closed out everything. I opened Excel and I picked the top corner and I hit paste and everything showed up and I'm like, woohoo, and I ran out from there.
Yeah, if you right-click on the design table in SolidWorks, it'll have an option to save it.
It does, right? And I apologize. That's
It
right.
saves an Excel file.
Yeah. And in fact, if I take a look at it, that's a great point.
Failure he was talking about yesterday.
Is it
It was fortunate I restarted it.
Yeah, that's right there. Right-click, save table. So
Yeah, there you go.
I forgot you don't have to do the copy-paste. Yeah. Yeah, see what you remember after 20 years, right? All right, so configurations, and really what it comes down to, multiple personalities aren't that bad as long as they get along. They weren't getting along today, so they're going to get a timeout.
Okay, you're going to say it more often. Right?
Yeah, save often, right? Yeah, I don't do that. Equations. Here's my deal. I'm an application engineer who does training. I do tech support. I do all kinds of cool stuff with SolidWorks. And the one thing that I see, the biggest mistake of everybody out there, is you guys do way too much math in your head, all right? I will attest. I'm going to call Bruce out. Bruce just took my Essentials course on how to use SolidWorks. And Bruce, what was one of the things I told you not to do? Not do math in your head, right? If you do math in your head, how many of you guys are familiar with the term design intent? Show of hands. All right, what does design intent do for me? It does my work for me. That's what it does, right? And if I put good design intent into a part, I'm awesome. But if I do math in my head, I'm not doing that in the part, and the next person doesn't know the math I did in my head, and they don't know the changes and how that works, and then all of a sudden we run into a really bad, ugly place. Now, so hence the title, Math is Bad. Except equations, but equations are math. So I guess math isn't bad, but you got to do the math the right way, okay? Now, I kind of want to show you this a little bit. We'll get into what's going on here. And, you know, one of the things we can take a look at is a model that I have right here. Let's go in and go here and then equations. All right, so new functionality inside of SOLIDWORKS we got a couple years ago is the ability to adjust a pattern based on length or adjust the quantity or adjust the spacing. And it's something that I will say I've created a lot of equations for. You take the length, you subtract this, you divide by this, you minus 1 because for whatever reason we have to, and eventually we could get something that we could come in here and very easily sketch or stretch, and we would have the ability to update the pattern as necessary. So you can see that the holes are adjusting their spacing. Now, that function is based on the pattern, and if I get in here and edit the pattern, we'll see that we have the new up to reference function that we got, like I said, a couple years ago. So if you guys are using 2014, I don't think it was there. Maybe it was. So I have the whole pattern, and this is one of those things we had to do frequently, or maybe we had to change the number. And SOLIDWORKS has done a really good job. You can see that we can say, hey, I want to control the number, or I want to control the spacing. If you control the spacing, when the part gets long enough, it throws in a new one for you every time. So kind of a nice function. It did alleviate a lot of the equations, and then it dawned on me the other day that while we have it for linear fashions here so that we can stretch this and make it, you know, change up, we don't have one for this down here, the ability to add more holes or change the spacing on a circular pattern, all right? So what I'm thinking here is like, let's throw in an equation to change the space, or not spacing, but change the number of components that are in here. So as the flange or as this disc gets bigger, I want more holes to be added in, because if this goes from 100 to 300, I don't think 6 little bolts around the corner is going to be really helpful, all right? So some of the things I did here is I put my sketch together in such a way that as I stretch this and make it bigger and smaller, the holes moved with it from the outside. There's no equations there. This is a simple geometric control. Now, what I want to do is the ability to stretch this out or change this number, and then as it gets bigger, more holes are added. As it gets smaller, less holes are, or more holes are taken away. Less holes are added. That doesn't make sense, right? But that's kind of what I mean. You get me? All right. So I'm going to go ahead and roll back here. And I'll get to the point where it's just the part on the screen so we can kind of deep dive it a little bit. One of the things that I like to use here is the Annotations folder up at the top. And especially when I'm working with design tables, or if I'm working with equations or configurations, I do like to right click on the Annotations folder, and there's something called the Show Feature Dimensions. The reason I like this is when I turn it on and I do a rebuild, I see all the dimensions involved with the part all at one time. So I have the thickness here, I have the diameter here, I have the size of the hole, I have this over here, which is the offset from the outside, and then I also have this number 6 that's right out here. What I want to do is I want to control this number, and the way that you control this number with an equation is you start by double clicking on it. So same thing happens with Excel. If you've ever had a cell and you want to go ahead and modify the cell, you start by picking the cell, hit equals, and now you're in summation, and you can start typing things in. So I'm going to do the same thing here. And I'm going to double click, I'm going to hit the equal sign, and I need to start telling it what it's equal to. Well, what I want to do is I need the circumference of that circle that I offset that my holes are sitting on, and then I need the circumference of that. So if I do a quick Google search, because I was questioning myself, I found out it was 2 pi r. I'm like, yay, all right. But then I'm like, wait a minute, I got a diameter. So then I'm like, well, can it be d pi? And then so I tried it, I wrote it on paper, and I figured out it's okay. We can just do pi d, and we'll be good.
22/7.
What's that?
22/7.
22/7. No, don't do that. You're confusing me.
22 divided by 7.
What do you? No. Is that like,
That's the fractional.
oh, is that what it is? Yeah, no, don't do that either, all right? That's actually really good that you brought that up. Well, I guess you could do 27 divided by 7, or, yeah, okay, yeah, thanks, rain lady. So we got the dimension here, and this is actually, you bring up a good point. Like, we know the fractional value, there's all kinds of things. I know it's 3.14, that's all I remembered. I didn't care about the rest of the numbers, but you have people that are prideful to go to 5, and they go to 8. You run across the nerds that know it down to 20, 30, 40, 50, and you're like, okay, get out of here. All right, so the beauty of it is equations, you can do basically anything up to trig or calc functionality, all right? We can handle anything trig, so your secant, cosine, sine, tangent, all that can be added. In fact, just to kind of see that underneath here, if I pick equals and I hit function, you'll see these are all the functions that I can do. So sine, cosine, tangent, secant, cotangent, blah, 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 blah. Absolute values, exponentials can be added in here as well too. We have logarithmic, square roots, integrals, and well, I guess that's an integral. And then you have the, I don't know what that is saying, but what is it?
If statement?
No, there's an if statement. What's the SGN?
Square root.
Is it square root? Oh, that's the SQR. I don't know what the SGN is, so $5 payable by the guys who run the user group if you can figure that out. So. Should have muted that. All right. We do also have if-then statements. The if-then statement works like it does in Visual Basic, which, once again, I saw the writing for it, and I'm like, I don't know. And then I talked to my brother who is a Visual Basic programmer. He's like, oh, it's easy. Click, 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 and Control F9, whatever. So you can do whatever you need here. You also have the functions like a calculator, so times. You can also group things together in parentheses as well, too. Make sure you check your parentheses just like we had to back in algebra. And, you know, everything there. On top of the fact that there's other ones that aren't even listed here, pi being one of them, all right? So what I need to do here is I'm going to take the circumference and then I'm going to divide it by a number. Like, I want my holes always to be at least 40 millimeters apart. If they get a little bit farther than that, it's going to go ahead and throw in another hole for me at that point. So the way I do that is this. I'm going to go ahead and open some parentheses here, and I'm going to say that it's the diameter. Well, I have the diameter listed up there at 60.35. I don't want to type 60.35 though, right? Because if I type it in, that means that's a hard number. I need it as a variable. So the way I do that is I come over here and I just double click or click once on the dimension, and that's going to put that information in there. One thing I do want to point out, that dimension is a read-only dimension. It's a driven dimension. So all I did was I put a dimension on it to get a value to work with. Now, I got that, and I need to multiply it by pi. Type in pi. That is going to be the actual, you know, number that it's going to use. If you type in 3.14, you're going to have those inconsistencies, and we can only go down 8 decimal places, so we'll still have those inconsistencies. This gives me the perfect pi if I type it in. Sound good? I'm going to close parentheses out, and then I'm going to simply divide this by a number. I'm going to go ahead and pick 40 for now. I'm going to hit enter, and if I hit enter and it doesn't turn red, that means I have everything okay. One of the things you have to realize with equations, you have to have a real number. And I don't mean like, oh, it's a real number. It has to be positive of 0, can't be negative, can't be imaginary, can't be a negative square root, which is imaginary. It can't be anything like that, okay? So if you ever get an error, the best thing I can tell you is don't cuss at the software. Write down your equation, run it out by hand. I had a customer do this. They had this massive equation, kept on failing out, couldn't figure out what it was. So finally, I'm like, I don't even know what you're trying to do here. So I started just writing numbers down, wrote it all down, came out to like negative, you know, it was the square root of negative 2.6 or something like that. And I'm like, oh, there's your problem, right? So it's an imaginary number. Negative numbers are always no-no inside of SOLIDWORKS. In fact, one of the things you can do is once you have this, you can put the absolute value. So if it does go negative, it at least will turn it to the absolute number and be okay for you. So just kind of keep an eye on it. Lots of checks in there. Just use your old algebra stuff at that point. Now, I do want to check the value of it just to see what's going on here. And we can see that it's 5. So my 40 is a little bit too big. It's actually, for this particular size, it's actually going to shrink it down a little bit, which is actually okay because I kind of messed around with that already. So I'm going to go ahead and accept that. And that number will now have a sigma sign next to it, meaning that it's being controlled by an equation. So that'll be the best thing you have going for you. And if I come in here and do the instant 3D stretch thing, which I grab the dimension and I stretch it, we'll see that as it gets bigger, you'll see that more holes will start to be added in when they can get fit in. If it gets smaller, it'll go down. Don't take it below 1, right, or 0. So equations, they can be used for all kinds of things. Either you're controlling a pattern, you're controlling a length. I could say that the thickness here is equal to this dimension times 0.15. Apparently SolidWorks didn't like that. We'll see what happens when it does start to like it. There you go. And so as we move this out,
Ooh, if you take it to 0,
don't do that. Black hole opens up, sucks your part, crashes out SolidWorks. So here what we're seeing is that as we make that outer diameter bigger, not only is it controlling the holes, but it's also controlling the thingamajiggers down there as well too.
Can you control that by like at an increment? Let's say, as it gets bigger, increase by 5 million.
That's where I think the if-then statements come in, because you can say if it's between this and this, like you can put something together that will do that. And where I've seen that is the if-then statements. And someone asked me, I'm like, I'm not sure, maybe the if-then statements. He's like, oh yeah, maybe so, because he had programming knowledge. And then he came back like 10 minutes later and showed me this thing, and I'm like, wow, I don't know what's going on, but he made it work. So
I tried putting the if-then statement in
yeah, how'd that work for you? Yeah, there you go.
I can do it myself.
That's something I could, we would probably need to take a look at, make sure everything was good there. Hey, look how many times I can hit tab. There you go. Like questions and answers. So kind of got to an end there. We got a couple minutes to wrap up here. As far as the questions, you can read the dialogue underneath. So if it's too big, I can't answer it. If you see me dance around too much, it's not that I don't know the answer, it's just I don't know what answer to give you. Yes, sir.
When the table dialog opens up,
Yep.
is there something you do with that window? Or what can you do with it?
So when you go, so when you go and edit the table, you get this window, and I kept on shutting it down, acting like, oh, it's not even here, right? I ignored the elephant in the room. That's actually pretty beneficial. And one of the things that I probably should have shown you, but it was one of those things that I was just want to stay real focused on what was going on in there. When I added that feature into it, and I said, oh, I need to modify the table to add that feature to it, it actually was in the list on the bottom. So instead of me blowing out that table and then double clicking on it, and that's probably where things got screwy, I could have just picked it from the list and said add it to the table, and it would have actually auto-populated in there. So if you add something, it's usually going, hey, do you want to add this to the table? It's trying to make it so it's a little bit easier and less of you double clicking and moving and scanning and stuff like that. So there are options that you can turn it off if you don't want it to keep on popping up. And normally I turn it off, I just forgot to today, but it's actually pretty beneficial. I didn't like it for many years, and now I'm kind of going, oh, well, it's actually doing a lot of work for me. So, does it explain it? Anything else? Yes, sir.
Any, I guess, rules of thumb or anything on configurations in assemblies that are going to be different than configurations in the parts?
Yes. All right. One of the things that I actually hit upon it on the next lesson, or the next thing I'm going to be talking a little bit about that, but it helps everybody know it as well too. So if this is what you came for and you don't need anything else, you're awesome. Keep on going. One of the things that I see happen frequently is that people will use a design table or configurations at an assembly, and then they will try to control the length of a part. And you can, and it kind of works, but it doesn't work very well. Usually what happens there is that you can control dimensions and suppression states at a design or at the assembly level. It works out great for that, for all assembly features and stuff like that. So if you're trying to control the length of a sketch in a part, what you need to do is you need to have a configuration in the part that we can now call to. So if you have two different sizes of a part, you don't control that size at the assembly, you control what configuration of that part you're going to look at the assembly. So that's usually one of the biggest things we run into. I will say that the next lesson is a little bit of or the next presentation was a little bit of a struggle. I'm not a big fan of configurations at assembly levels, except for very, very light stuff. opening panels or moving a robot arm or something, showing different positions. Switching things out just seems like a real big compound coming kind of together. I do talk about it in the next session, but I'm not a big fan of it at that time either. So, but yeah, that's about it. Just don't try to control parts. Control configurations of parts. Don't control the part directly. It's never gonna work. You think it works, it doesn't work. Anything else? Yes, sir. Oh, not you, but you.
In your opinion, how many features should you change to make a configuration before you actually change the model? State.
Oh, like do like a save as and make a whole new part?
Make a whole new part. Yeah.
So just to repeat it, how many questions or how many things would change before you finally go, forget it, I'm going to go and make a brand new part? Maybe so. That's what I'm going to say down there. There's really no hard set number. I tend to, the more people I work with in a group, last place I was at, we worked with 80 people. I've worked at other places where it's a very tight-knit group with 3 people. It's really dependent on what you think you can handle and the group can handle at the same time. I will say that the larger group, I tended to not use configurations at all because it just caused more headaches than not. And it was very hard. It was amazing. Well, we've heard it before, mob mentality. The bigger the mob is, the lower the IQ. I had a mob of engineers and designers I worked with, and it held true. So really no hard set number. When you feel it's getting out of control is probably the best thing, is just to kind of, it's a gut feeling. So.
And how it opens very, very slowly.
What's that?
When you can't open it, it's very, very slow.
Yeah, actually SolidWorks has made some good changes to that as well too. That was something that used to be a problem because we used to store information of every configuration when you save the part, and that was about 2 years ago that they finally changed it. This is where we got the little checkbox and minus sign. They tried to do better at it, but there's also one thing that you have to be aware of, and I'm not sure if everyone is if you're using configurations and a lot of configurations, Microsoft has a memory leak that for some reason we happen to dovetail with. It's not something we can do on our side, it's actually a Microsoft issue, and you'll see that this memory leak basically makes your part bigger and bigger over time, and sometimes it's just opening the part and saving it will add 10 meg onto the file. And then you go and add a new configuration and it goes half a meg bigger. And then you add, you open it up and close it and use it in assembly, and now 20 meg got added to it. So every once in a while you're like, man, this is taking forever to open up. You open up the file and you take a look at the file size, and it's a screw with 20 configurations, and it's coming in at 250 meg in size. All right, so kind of check that out. That might be something you want to look at. An easy fix for it is to do a file save as, delete the old one, rename the new one to the old name, and everything seems to work out. It's back to the 1.5 meg. But take a look at it in 6 months. Don't be surprised if it's at 180 meg again. So don't know what it is. Microsoft won't fix it. It's easy to get SolidWorks to fix things compared to Microsoft, I'll tell you that. So you tell Microsoft they got a problem, they're like, no, we don't. And we're like, yes, you do. And they're like, well, we'll pull our license. I'm like, I'm all set. So there you go. We had another question in the back.
Yeah, I was just going to ask if you have any advice, I guess best practices, kind of advice for using part numbers and configurations, and what field you store the part number in the configuration, so that you can access the part number in your detailed drawings. Is there best ways and bad ways of doing that?
Yeah, so the rules of thumb for putting part numbers in for configurations really depends on what's going on. I have seen some companies that will make a special file property for it, and they can control it through the configuration manager and stuff like that. The bill of materials actually has functionality that will allow me to simply pull the name of the configuration in, and then under the configuration properties there is a checkbox to say, hey, if I'm used, this is what I want shown. One of it is the configuration name. You can write a number in there, or you can just say use the file name, which will kind of trump anything that you were looking for. So, but it does need to be hand managed at that little checkbox level. So if you get someone that creates 10 configurations and doesn't do any of that work, now you've got 10 configs that don't come up right, and it's confusing, and it takes you like a half day before you realize that someone forgot to put the little checkbox on. So if you have a PDM system, then you track down who did that, and then you do some stuff to them, but that's another, probably not recording would be good for that. So does that help a little bit?
Well, we kind of dabble in all of those, and so I was wondering if there's any advice.
Yeah, I would personally make it the configuration name and then make sure that the check is checked that says use the configuration name for the description or for the part number for the bill of materials at that point.
Okay.
Anything else? Did you guys learn anything? Was it a little helpful, hopefully? All right. All right, I'm all set. I appreciate your time, guys. Thank you very much. And then if you're going to be in the next session, I'll see you then. If not, thank you very much. I do appreciate you coming.